So larger MOSFETs will exhibit less 1 by F noise because their large gate capacitances will smoothen the channel charge. So large MOSFET means the MOSFETs whose dimension is very large. So those MOSFETs will have a lesser 1 by F noise. Okay, so and corresponding to their smaller MOSFETs. So if a good 1 by F noise of performance is to be obtained by MOSFET, you have to use large MOSFET devices or MOSFETs having larger channel length. Okay, so same way we are seeing what is the drain current because of this flicker noise. So the RMS value of drain current is given by K by F GM square by WL C aux square into delta F. You know, again, K is a device specific constant, and all these flicker noise you see, you have a term 1 by F. So this 1 by F is going to indicate the variation of nonlinear variation of noise with respect to frequency. You know, GM is the trans conductance in MOSFET, W is the width of your channel, L is the length, width into length becomes area, and Cox is the gate capacitance into delta F. You know, delta F is going to be the noise power bandwidth. So if you simplify, you can write this as K by F into omega T square into A into delta F, where omega T square is given by this expression. So omega T square into A will be equal to this expression. So if you, how can I minimize this noise? When you have a larger area, I can minimize this noise. Or when I am going to have a thinner dielectric, I can reduce this noise term. Otherwise, you cannot reduce this noise. Larger area means the length will be larger, the width will be larger, which is what we are saying it as larger MOSFETs. So the channel length and channel width of the MOSFET, if you make it larger, that will predominantly reduce the flicker noise in the MOSFET. But again, if you make it larger, the application for which you're developing MOS, the size will become bulky. It might not fit your criteria. So you have to have a compromise between noise, the channel parameters, and the MOSFET design. Because just to minimize this noise, flicker noise, I cannot blindly increase the channel area, right? So you have to have a compromise or trade-off between all the parameters. For PMOS devices, the K value is very, very small, 10 power minus 28, whereas for NMOS devices, it is 50 times larger. That's what I said, this K value, you are measuring it from the device. After fabricating a device, you subject the device to different frequencies and you find the noise power. And from that, they derive this value of K. So when K value is larger, noise is also larger. So one thing from this what is clear is PMOS device will have a superior performance over NMOS device. So when it comes to flicker noise, PMOS will perform better when you compare to NMOS because the K value is very much less between PMOS and NMOS. It's for PMOS, the K value is 10 power minus 28. For NMOS, it is 50 to 10 power minus 20. It is 50 times larger. So the noise power will also be 50 times larger. So these constant value of K, what they find out, right? So that will vary from process to process because they are all done by experiments and computer simulation. So you cannot expect this K value to be constant always. So it will vary from time to time and experiment to experiment. So if you conclude with this value of K, we can say in particular the superior performance can be expected from PMOS device when you compare to NMOS device, but we don't prefer PMOS device because you have a lot of holes. Holes are minority carriers and they move very, very slowly when compared to electrons. So speed becomes a problem. But when you compare noise, PMOS is better. So you don't come to a blind conclusion that I'm going to replace all NMOS by PMOS. No, the PMOS still has lot of issues. I again say all possible options are given to the company. The company people will decide which one to fix. So if the product is more about concerned about noise, then they can think of using PMOS over NMOS. But if noise is not an issue at all in their product, then they will never go for PMOS. They will go only for NMOS devices. Okay, so all this suggestion given by the theoretical investigator to the company saying these possibilities are there, you use the device accordingly. Okay, we cannot come to a conclusion just by a single parameter.